really talk about how to graph exponential functions without really exploring what happens to them with some technology here. So I'm going to go put a very basic exponential growth function up here. I know it's growth because I'm going to have my base be 2. I'll raise to the x. So here's my parent graph of 2 to the x. All right, notice my parent graph goes through 0, 1, because when x is 0, anything to the 0 power is 1. My parent graph is growth because that base, that 2, is bigger than 1. I also have a couple other things I want you to notice here. As I ride or slide down this graph, I become more and more and more and more horizontal. And I have a fence down here that I can't get past here at ground level. At y equals 0 or on the x-axis, I'll never get past it. Mathematically, it's because as x becomes more and more and more negative, like suppose it was x to the negative 100. 2 to the negative 100. I'd have 1 over 2 to the 100th. It'd be incredibly small, but still positive. That's called a horizontal asymptote. That fence down there at y equals 0 that I just ride along on out, not only to the end of my graph, but to negative infinity as well. So we're going to be talking about our horizontal asymptotes. Also, I want to bring back the concept of domains and ranges. Remember, domain is anything x can be. Well, I can raise 2 to any power. X can be anything. Remember, the only things we can't do are divide by 0 and even root negatives. That's not an issue here. So I've got my domain of all reals. My range, though, is what comes out or what y can be. And I just said we've got this fence down here at y equals 0. My values, my y values, are always positive with this exponential function. So I'd say my range is y greater than or equal to. I'm living above the x-axis. So y greater than or equal to 0. Now let's start some transformations. Let's see what happens. We should know that when I subtract 3 with the x, the graph is going to move 3 to the right. So 3 now has me up at 1 because x equaling 3 causes me to have 2 to the 0 or 1. So you'll notice my 0, 1 got shifted 3 to the right. It's now at 3, 1. So that number in there with the x does what it's been doing for all of our function transformations. Does the opposite of what we would think. So that goes 3 to the right. If I hit a plus 4, we should know that that's going to move the entire graph up 4, including the horizontal asymptote. And it's also going to, although it doesn't affect our domain, x can still be anything, all reals. Our range is now, this function's y values or its outputs are always above y equals 4. So we'd say y greater than or equal to 4 is our range. This tail number on here, this 4, tells us a lot about the graph. It tells us horizontal asymptote at y equals 4. It tells us that our range is y greater than or equal to 4, unless we do one more transformation. What do putting negatives out front do to our functions? Multiplying y by a negative flips it over. It did it for parabolas, and it did it for absolute value, and it's doing it for exponential functions. What changed? My horizontal asymptote is still up here. I'm still riding along y equals 4 on out to negative infinity, but now I'm below it. So my domain is still all reals. My range is now y less than or equal to 4. So we are seeing what these numbers are doing to the graph. Let's go back to the parent function. All right, if you were asked, what is this going to do to the graph? Plus 4 in there with the x, minus 3. You would say it's going to shift it 4 to the left and 3 down. What is the horizontal asymptote? It's this fence down here. It's controlled by this minus 3. So it's y equals minus 3 or negative 3. And then how about the range? We're living above the fence, so y greater than or equal to negative 3. In the domain for these, no limitations. X can be anything, so all reals. Now that we've investigated our exponential graphing, let's go take a look at y equals a base of 1/2, exponential decay, it's less than 1, to the x minus 1, a shift 1 to the right of the parent function, minus 5, a shift of 5 down. What will you be asked? Describe how the graph is related to the parent function. It's going to be shifted 1 right and 5 down. It won't flip over the x-axis or have a flip because there's no negative in front of those parentheses. We'll be graphing it in a little bit. How about the domain? All reals all the time for these. X can be anything. So our domain we'll say is all reals. We know that that minus 1 shifts us 1 to the right. The minus 5 shifts us 5 down. Remember that minus 5 also controls our horizontal asymptote. It's at y equals negative 5. We saw that in our Desmos exploration. So that minus 5 down there is controlling not only our horizontal asymptote, but our range. Because that's a fence that we'll be graphing down there at y equals negative 5. And we're going to be living above that fence. So our range, y greater than or equal to negative 5. Our horizontal asymptote, y equals negative 5. Our domain, all reals. And we already said a couple of times, it's a shift of 1 to the right and 5 down. Now let's go actually graph it. After exploring on Desmos and discussing, we're now ready to graph. So first of all, let's discuss the graph of the parent function, y equals 1/2 to the x. That's going to go through 0, 1, because anything to the 0 power is 1. As x gets bigger, my y is going to shrink, because I'll be doing 1/2 to the first, which is a half, and then a half times a half, and then a half times a half times a half when I do a half to the third. And so I'll gradually be approaching y equals 0, or my horizontal asymptote. And to the left, I'll be increasing, because when I do a half to the negative 1, I flip it and do 2 to the first. When I do a half to the negative 2, I flip it and do 2 to the second. So I'm going to have exponential decay because that base was less than 1. Now, we already know that we are going to have a shift of 1 to the right. So I'm going to grab this point right here, 0, 1, and go 1 to the right and 5 down with it. 2, 3, 4, 5. Now, I'm gradually going to be going like this, same behavior, and gradually be going like this, same behavior. I now just have a new horizontal asymptote. My horizontal asymptote has also been moved down 5. So it's down here is my fence at y equals negative 5. My domain, all reals all the time for exponential growth and decay. My range, I'm living above that fence or above y equals negative 5. So all reals, y greater than or equal to negative 5, y equals negative 5 is my horizontal asymptote. Again, this guy's in control of both my domain and my range.